Newton's ring experiment. The aim of this experiment is to determine the wavelength of sodium light by Newton's ring. The apparatus will be a monochromatic light source, which will be a sodium lamp here, a mount at the bottom of which we'll place the flat glass plate and a plano convex lens such that the curved surface of convex lens is placed adjacent to the flat glass plate. There will be also a reflector fixed at the top of this mount which is used to direct the light coming from the light source to this optical assembly. We will also require a traveling microscope to take the readings. Theory. The phenomenon of Newton's ring is named after the scientist Sir Isaac Newton, which is an interference pattern caused by the reflection of light between the two surfaces. A spherical surface, which is plano convex lens here, and an adjacent flat surface, which is a glass plate here. Actually, what happens when the beam of light, monochromatic light, is incident normally on the combination of this plano convex lens and the glass plate, a part of each incident ray is reflected from the lower surface of the lens and emerges as E, and a part of this incident ray get refracted through this air film between plano convex lens and glass plate and reflected back by the glass plate and emerges as F. These two reflected rays are coherent, and as the lens is symmetric along the axis as well as the thickness is constant along the circumference of a ring for a given radius, the interference pattern of these two reflected rays will be the system of alternate dark and bright circular rings. These rings are called as Newton's ring. Here is the procedure for performing this experiment on a virtual platform. For performing this experiment on the virtual platform, we just have to type Newton's ring experiment virtual lab on Google, and it will direct us to a website of providing a virtual platform for this experiment by amrita.edu. We can simply log in this website if we already have the login ID. But if you don't have the login ID, we just simply free sign up, register the details and get the login ID and password. After logging in into this website, there will be a screen showing that asking us to enable Flash Player for this particular website on Google Chrome. To do this, we have to enter the settings section of Google Chrome and then click this site settings. After clicking this site settings and going into vlab.amrita.edu, we have to allow the flash for this particular website. By allowing the flash for this particular website, the screen will be shown to us like this. It will include theory, procedure, self-evaluation, simulator, assignment, reference, and feedback for this particular experiment. By entering this simulator tab, there will be many options provided to us. There are options like we can select the medium between the plano convex lens and the glass plate to be air, water, acetone, etc. But we will select the air to be medium between the plano convex lens and glass plate for our experiment. There will be options for light source also, but we will select the sodium light source for our experiment. After that, we'll switch on the light. After switching on the light, we can simply see the circular rings of which are alternatively dark and bright to be shown in this view. We can select the radius of the lens of our plano convex lens, and as we can see, by adjusting the radius of the lens, the thickness and thinness of the rings are changing. After that, we can set the microscope focus to get a clear view. Then we can adjust the microscope position to either side of the rings. To start the experiment, we will set the microscope position to a particular ring such that the vertical crosswire is placed tangential to that ring. say 20th ring. For 20th left hand side ring, we can take the measurements. Here we can see there are two scales, main scale and the vernier scale. To take the reading from the main scale and the vernier scale, first we have to know what is the procedure to take the readings. Firstly, to take the readings, we have to know the least count of the microscope. Here, in this case, we can see that there are 20 divisions between the main scale, 2 centimeter distance of main scale, and 50 divisions on the full range of vernier scale. So we can know the least count of the microscope by this formula, which will come out to be 0.001 centimeter in our case. To take the reading, as we have already discussed, we first have to set the vertical cross wire tangential to the ring on the left hand side and start taking the reading, in which firstly we have to notice the main scale reading. The main scale reading is actually the reading on the main scale just before the zero of vernier scale. Then, to take the vernier scale reading, we have to see a particular division of vernier scale which is coinciding to the main scale. There will be only a one such division, as we can see here. So, by taking these two readings, we can calculate the total reading such that MSR plus CSR into the least count. Likewise, we can take the reading of the left hand side and the right hand side of the particular rings. We can calculate the diameter of the rings by subtracting this right hand side reading and the left hand side reading. Likewise, we can calculate the diameter of various rings like 20th, 16th, 12th, 8th, 4th, etc. Also, we can calculate the square of that diameter. After doing this, we have to plot a graph between diameter scale and the number of rings. The graph will be a linear graph simply because the as we move away from the center, the diameter of the rings will increase. So, by using this graph, we can calculate the slope of graph for mth and nth ring, which is dm square minus dn square upon m minus n. Then we can calculate the wavelength of sodium lamp by using this formula, which is the slope of ring multiplied by 1 upon 4r, where r is the radius of curvature of plano convexness. So this is how we can calculate the wavelength of sodium lamp by using Newton's ring. Thank you.